One of our favorite topics from math, quadratic functions. So to remind you, a quadratic function is one in which the highest exponent appearing on the variable is a 2, and that term must be there, so the coefficient a cannot be 0. Now, we're going to take an equation of this form and put it into this form by completing the square. I'm going to walk you through this process with an example. Here are the instructions on how to do it step by step, but I'm not going to follow these instructions exactly. I'm just going to show you the best way that I do it. Let's work with this example right here. So I want to complete the square on this. The first thing that I need to do is make sure the coefficient of the x squared is a 1. It's not. So I'm going to factor out from the x's only whatever is multiplying the x squared. In this case, that's a -2. So factoring -2 out of this term leaves me with a positive 1x squared. And factoring -2 out of this term leaves me with a plus 3x. I'm only factoring it out of the x term, so I'm going to write the -8 off on the side. Now, remember, if I were looking just inside this set of parentheses, my ax squared plus bx plus c, the a would be a 1 and the b would be 3, so I'm going to label that like so. B is 3. Whatever that number is, we divide it in half and then square it. B over 2 squared would be 3 over 2 squared would be 9 over 4 squared. 3 square the 2. You're going to add that inside the parentheses. Remember, if I'm working with an equation, if I add, I've got to subtract whatever I added to keep the equation balanced. But now remember your rules of distributing. This -2 is going to multiply that 9/4, so this one also needs to be multiplied by a -2 to keep the equation balanced. So now this would be -2 times x squared plus 3x plus 9/4 minus 8 is 16 over 2, that's 8. And then minus and minus is a plus. 2 times 9 would be 18 over 4, or 9 halves. Okay, now the purpose of adding exactly this quantity, the b over 2 squared, inside the parentheses, is that whatever factors and whatever is inside the parentheses will always factor into x minus this number, whatever your b over 2 is, this number, x minus this number, and the quantity squared. So in this case, x plus 3 over 2 squared. I said minus and I meant to say plus. X plus your b over 2 term, quantity squared. So that's why it's important you keep the sign with it. Now, -16 over 2 plus 9 over 2 is -7 over 2. Now, this parabola is now in my form for having completed the square. All right, so why do I want it in that form? Because that is my vertex form of the graph. I can read the vertex of the parabola. It's keep the sign on this guy, that h is the x-coordinate of the vertex. So change the sign on this guy and then keep the sign on the k. So hk is my vertex. The axis of symmetry will always be the vertical line x equals the x-coordinate, the vertex. Graph opens up if this number here is positive, and it opens down if this number is negative. And it's wider than the graph of x squared if this number is between 0 and 1, and it's narrower if this number is bigger than 1. Over here, my vertex for this guy would be change the sign here, so -3/2. Keep the sign here, so -7/2. And the axis of symmetry would be the vertical line x equals the x-coordinate of the vertex. I also know because of this negative out front, it opens down, and because this 2 is bigger than 1, it's narrower. Okay, let's graph it with that information. So negative 3 halves, I'm going to go negative 1, negative 2, negative 3 halves is right in between them. Negative 7 halves, negative 1, negative 2, negative 3, there's negative 4. So negative 7 halves is right in between negative 3 and negative 4. So in the middle here and middle here would be right about there. That's not supposed to be a straight line, guys, but I can't erase it. That just happened when I drew. It should only be this dot right here. All right, now I know that it opens down, but I don't know how to draw it exactly. So I'm going to plot one other point to help me. I'm going to plot the point where x equals 0. So if I plug in a 0 here and a 0 here, I get negative 8. So that's my next point this way, here and here. Now, since this is 1.5 over, remember a parabola is symmetric, so if I go 1.5 over this way, that'll take me to negative 3, and my negative 8 is there as well. So those line up. Now we're going to draw a parabola through that. And our parabola looks something like this. The axis of symmetry is this line that runs through the vertex, and my parabola is symmetric on each side of that line. Notice I dashed it in because that line is not really part of the graph, just this parabola is the graph. All right, now that we have that, let's, because that's what I was asked to graph here, let's find the domain, the range, and the intervals over which the function is increasing or decreasing. So the domain are the x values allowed in. So notice I can plug in any x value here. So my domain is all real numbers. My range are the y's we get back. So going from smallest to largest down here at negative infinity up to this vertex point is the highest point. So we're going to go from negative infinity. The vertex is at negative 7 halves, including. So that's my domain and range. My increasing, notice that I'm increasing when we're over on this branch. The graph is going up. So that's from x equals negative infinity to the x coordinate of the vertex. So negative infinity to negative 3 halves. And then where I'm decreasing is this way. Going this way on the x, the graph is going down. So that's negative 3 halves to infinity. Notice I included open circles on both the increasing and decreasing because at a single point, I'm neither increasing nor decreasing. Now notice that also the vertex here is the highest point on the graph. Okay, now to do this on your calculator, you would go into the y equals and type the equation. I already did that for you. And then I can just hit zoom 6 to bring up a standard 10 by 10 window. And it's going to draw that graph in there for me. I can use the trace key to move along values along the graph. We're also going to talk about some of the values you can see in the calc menu coming up in other menus, other lessons, including the maximum, the minimum, finding the zeros, and so on. Okay, now, how did we get to that vertex form of the parabola? Well, notice that if I complete the square on the general form for the parabola, I can write the p of x as y, divide the a so the coefficient of the x squared is 1. Equivalently, I could have factored it out. And then take half of the term in front of the x, add it to, square it, and then add it to both sides of the equation and simplify. What's going to happen is when I complete this general form, this is my x coordinate of the vertex, and this will be my y coordinate. I'm not really concerned about this. I'm going to focus on this right here. This formula gives me a way to find the x coordinate of the vertex without going through that completing the square process. That's going to be my x coordinate of the vertex. Plug it into the equation to get the y coordinate of the vertex. So here, my vertex, the x coordinate coordinate is negative b over 2a. So this is a is 5, b is 10, c is negative 2. So if I look at negative b over 2a, negative 10 over 2 times 5 gives me an x-coordinate of negative 1. Now, to find the y-coordinate, I plug negative 1 in here. So I'd have 5 times negative 1 squared plus 10 times negative 1 minus 2. So we get a negative 7. So now what this tells me is that my vertex is at negative 1, negative 7. Again, I can find the x-intercept, or the y-intercept by plugging in x equals 0 to the equation, and y would be a negative 2. Notice I moved over 1 to get to the negative 2, so I would go this way 1 to get to the negative 2. Notice this graph is stretched vertically. My domain, again, is all real numbers. I can plug in any x. My range, the lowest value, by the way, this is not a point, this should be a smooth curve. My lowest value is the negative 7. So it's going to go from negative 7 to infinity. I'm increasing from negative 7, negative 1, the x value of negative 1 to positive infinity. And I'm decreasing from negative infinity up to that x value of negative 1. All right, so that's how I'm going to be able to quickly graph the function using either the completing the square or the finding the x-coordinate of the vertex. We're going to talk about extreme values in the next video.